So children, by looking at this particular question, that is 13th question, it was very clear that it is from current electricity chapter, right? So from the basics that we know, we could do this question. One is Ohm's law, V equal to IR, and another one is that series and parallel analysis. Okay. So look at this circuit carefully. Now these two resistances are in parallel. Okay. So let me write parallel. And these two resistances are in parallel. So first of all, we'll simplify this circuit, right? So when two ohms resistance are in parallel, what is the formula? So we know that resistance in parallel is given by R1 into R2 by R1 plus R2. This is the formula. So here we are having two ohms. So that is 2 into 2 by 2 plus 2. So answer is 1. So in place of those two resistance in parallel, let me draw only one resistance whose value is just 1 ohms. Okay. 1 ohms. Very next to that, we are having 2 ohms resistance in series. Very next to that, we are having 20 and 5 ohms in parallel. So we have to simplify this, isn't it? So 20 and 5. So 20 into 5 by 20 plus 5. So which is equal to 20 into 5 by 25. So 5 5s are 25 and 5 4s are 20. So this is 4. So answer is 4 ohms. So now the resultant of these two resistances in parallel will give you one more resistance, that is 4 ohms, which is in series with the remaining one. And the last one is again 2 ohms. So like this, we are having 4 resistances in series, which is connected across voltage source plus minus 24 volts. Students, but you have to be very careful that this voltage source is having some internal resistance, okay? So there is nothing but 3 ohms. This also we could, so we have to substitute. So here there is 3 ohms. Now, look at this circuit. So what I mean to say is that because of this voltage as per Ohm's law, there is a current I coming out from the positive terminal. So this is positive, right? Coming out from the positive and then moving through the entire circuit and again ending up at negative. So like this, okay? So if you observe carefully, what are the current coming out from this 24 volts? The same current is passing through 1 ohms and the same current is passing 2, 4, 2 and this 3 ohms. It means that if the current flow is same, no doubt all are in series. So now this is nothing but series combination. So in series combination, what is the formula? Resistance in series is equal to R1 plus R2 plus so on like this. So here 1 ohms, 2 ohms, 4 ohms, 2 ohms and 3 ohms all are in series. So the resultant answer will be, okay, 1 plus 2 plus 4 plus 2 plus 3 like this. So 2 plus 1, 3, 3 plus 4, 7, 7 plus 2, 9 and 9 plus 3, 12. So the answer is 12 ohms. Now this circuit can be modified as a single resistance of value 12 ohms which is connected across a voltage source, that is 24 volts like this. So now you are having voltage as well as the resistance in the circuit. So with this we can find out current just by using a Ohm's law, I equal to V by R, isn't it? So as per Ohm's law, you could find out current I. So I is equal to V by R, that is 24 by 12. You will get it as 2 amps. So the current that is flowing here, it is only 2 amperes. But look at the question, what he is asking. The values of I4 and I5. Values of I4 and I5. So what is I4 and I5? Check carefully. So this one, the one that is flowing through R4 can be named as I4 and the one that is flowing through R5 can be named as I5 like this. So we have to, our interest upon is that we have to find out the current flowing through 20 ohms, okay, and current flowing through 5 ohms, these two. Clear? Now, I would like to erase it. So, okay children, so here I4 and I5, these are the two currents which we need to find out, and the current that is entering here, so that is 2 amps. So here 2 amps is coming out, so here also 2 amps. In these two places current is divided, so both are equal values, so half of the current flows here, 1 amp. Directly you could say like this. So again this 1 amp and 1 amp comes here. So they'll combine and now they'll become 2 amps. So here this 2 amps is flowing. Okay. Now again it get divided. So we know current division rule as per CDR, current division rule. If I want to find out the current in first resistance, then what I have to do is the total current into other resistance by sum of these two resistances like this. But here we are having R4 and R5. So let me say I4 is equal to total current I that is entering. So here total current I is nothing but 2 amperes into. So look my dear children, it's very carefully here. So if I want to find 1, I have to write here 2. If I want to find 4, then what I have to write here? 5. R5 by R4 plus R5. This is the way I'll write. Similarly, if I want to find I5, then I into R4 by R4 plus R5. Like this I have to do it. Okay. So now let me substitute its values. So total current I is 2, where R5 is 5 ohms, R4 plus R5. R4 is 20 and this is 5. So it is 10 by 25. So 5 2s are 10, 5 5. So the answer for this one is 2 by 5 amperes like this. Whereas here it is 2 into R4 is 20 and it is 20 plus 5. So 2 into 20 by 25. 5 5s are 5 4s are. So which is equal to 8 by 5 amperes like this. Okay. So we got I4 and I5. So finally what we could say is that the current flowing through this R4, that is I4, okay, I4 is equal to 2 by 5 amperes and I5 is equal to 8 by 5 amperes. So this is what is the answer. Now look at the options carefully. If you look through the options, okay, in the first case I4 and I5 has been reversed. So this is wrong. Okay. Now, so this is wrong, reversed. So this is also wrong. This is also wrong. So this is right option. Fourth option. So I4 is 2 by 5 and I5 is 8 by 5. Okay, children. I think it's very clear. Okay. So we'll move for the next one.